Hi there, good morning. Today we are on to part 2 for AS Lower 6 Physical Chemistry on atomic structure. Now, if you look at the syllabus, we have done the first part here, physical chemistry, atoms, molecules, and stoichiometry. We have covered, I went through actually the first and the third. We'll do the mole and Avogadro's constant later when we do the calculations, okay? We have talked about the definitions and use of the relative atomic mass, relative isotopic mass. Today I'm going to give you the definition for relative molecular mass and relative formula mass. Now, you must remember here, I told you earlier, that the relative formula mass in the olden days, let's say here, okay, so I put a blue color so you can tell the difference today I'm talking about. So, yeah. The relative formula mass, what's the difference between this one here? Relative formula mass and relative molecular mass, okay? Relative molecular mass. So last time there used to be a term called relative molecular mass, okay? So now they combine both together now, all right? So relative molecular mass, if you want to bring it, is only for covalent substances, okay? Relative formula mass is, when the formula here means that is for ionic compounds. Okay, they are both for compounds, okay, for compounds. Okay, the only time the relative molecular mass is used for elements is when I told you earlier that there's like FCl2, right? All these things here, F2, diatomic. So they call them, they're molecules, right? You know, these are molecules, right? So they have to use relative molecular mass for all these things here. But normally they are used for what? They are used for compounds. So to differentiate ionic compounds and covalent compounds, they use formula mass and molecular mass. But now, as you see the marking schema, they put them all two together. I'll show you the question, okay? Now I'll show you my notes first for relative molecular mass and relative formula mass based on carbon-12. I look further down here. We have gone to the first one already, the first two. Okay, now here, relative molecular mass, okay, MR. This is a famous MR, okay, MR. Okay, you use MR a lot in your calculations, MR, relative molecular mass. Okay, it means it's for any compound. So I put it on an element, of course, the element like Cl2, O2, O3, H2. All these are also called Br2. Okay, all these are also called. Like example, H2 is the MR for hydrogen. MR of hydrogen. AR of hydrogen is 1 or 2 or 3. I know. So it depends on the usage or a compound. Okay, now here the compound, of course, is for covalent. But now, it doesn't really matter. But I prefer when I use my molecular mass to talk about compound for covalent. But when you say for molecular formula mass, you can use for both, okay? For substance, the ratio, that means the ratio of the average mass here. Why average mass? Because for all your molecules, all right, all the compounds here, there's carbon, okay, this one H3OH. Now this is a compound, okay? So you can have oxygen 60, oxygen 70, oxygen 80 there, right? You have got 3 isotopes here. So in nature, you have to still use, because it's the actual mass of all the atoms of all the elements in one molecule. So because every atom here or every element here can exist as a isotope, that's why I say average mass. Basically, this means that there's isotopes. Okay. Right, so average mass of one molecule of the compound compared to, so normally this part is 1 mark, okay? It's the ratio of the average mass of one molecule of the compound, okay, with this 1 mark here, compared to 1/12 of the mass of one atom of carbon-12, where carbon-12 but this is the same, the 2 marks here. Now, for relative formula mass of an ionic compound, right? Because I think in IGCSE they ask, what's the difference between relative molecular mass and relative formula mass? They actually ask, this is a question I can show you later if you go back to IGCSE. Yeah. Okay, formula mass is specifically referred to for ionic compounds. But as I said, in AS, they don't really care. All right, they combine both together. I'm going to show you the marking scheme. I can see for yourself. So it's you need to know the marking scheme for every sort of these kind of things to clarify for yourself, so that your answer will be accurate. You score the marks. You don't care because you study one. It belongs to you. It's your right to claim the mark. Okay, it's a ratio of the average, again, average mass. Why average mass? Average mass because the isotope is there. So the isotope here. Okay, isotopes of one molecule, or they can say that average mass of every atom of the ion, of the ions, after I show you, okay, of the compound compared to 1 or 2 and so forth. So it's average mass of one molecule, can say one molecule of the ionic compound is to be accurately correct of the ionic compound. Okay, compared to this one here. So if you want to write it out in this way, I'm going to put the zoom blank here. Okay, so you want MR is equals to average mass of one molecule of compound. I want to show you the variation over, which means that compared to 1/12 times mass of one atom of carbon-12, where carbon-12 equals to what? 12 units exactly. Okay, so this 1 mark, so mark is 2 marks. Okay, so if I talk about the, it's also MR, no? This is lesson for formula mass. Remember, formula mass is basically for what? For other compounds. Same thing here, you put average mass, okay? Okay, you want to be a bit different, okay? Average mass of one molecule, or one more also, no? One molecule of, or mass of all the ions, okay, of an ionic compound. And over blah blah blah. This is the same thing here. Okay, now you don't believe me, you can look at the question and you can see how the answer is. I've got the thing ready for you already. Now let's say the question is in, let me see. Okay, formula mass 404. Okay, 404. Okay, this is 404 here. All right, same topic. Okay, so ammonium iron 2 sulfate. Now this is a complex salt, very big fella here, right? 2 positive charges here. One is, if you look at it here, this is a positive 1. This is a positive 2. Positive 3 actually. Positive 2. Because this 2 plus 2 plus 2 plus 4 is it? So it's minus 2 is it? So 2 here. Okay. So this has, so it's called double salt, whatever, complex salt. Okay. This is actually used in a lot of alums, whatever. Okay. Define here. Define formula mass. Relative formula mass, not relative molecular mass. Okay, why? Because it's a what kind of substance? It's an ionic substance. So they use the correct words here. They won't use relative molecular mass unless this is a covalent compound. Okay, for 2 marks. You can see the marking scheme. Now this, I think this one 2. Okay, see now. Okay, so here the mass of what? Now the first one is the mass of all the atoms of all the ions. Okay. Right, of a formula, right, or the mass of one molecule, right, or here is a better one, average, this is what I use, average mass, mean means average, okay, average mass of the formula or of one molecule, one molecule of the compound, see, average mass of all the atoms or all the ions in the formula, or one molecule of the compound. That is 1 mark. Compared to 1/12 mass of carbon-12, right? where it's 12 units exactly, it's like 1 mark. 2 marks. The second option is, of course, mass of, very bad, I think it should be average mass. Okay, I don't know why they don't, I would penalize in my marking scheme. Why average? Because there's average mass of 1 mole, okay? 1 mole of the compound. Or 1 mole, in this case, if it's ionic, 1 mole of the formula unit or the ionic unit of the molecule compared to blah, blah, blah. So up to you, okay? So remember, if this is formula mass, you in your mind should think is of ionic unit. If it's just relative molecular mass, then don't have to worry about it. Just put general, okay? Average mass of 1 molecule of the compound compared to 1 over 12, the mass of 1 atom of carbon should be here. See, an atom is not, okay? 1 atom of carbon 12, where carbon 12 equals to 12 units exactly. So marking scheme, very important. You have to know it. Don't have you die. Okay, I've done this already. Now, so I've finished off all the definitions. Now we're going to go to determination. I won't go to the mole first because we want to do all the calculations together. So now we have done 1.1, 1.2, sorry, 1.3. Okay, now we're going to do this part here. 1.3, this part here. Okay, analyze mass spectra in terms of isotopic abundances. Right, knowledge of the working of the mass spectrometer is not great. Now, a few terms that you need to understand. Determination, that means I find out what's the value. Discover, find out. Okay, if you don't understand, determination is hard words, I know. Okay, relative, it means find out what is the relative atomic mass. Okay, it means of elements. Okay, AR ma. But actually, we also can find out MR after I show you. Okay, also can. So how do you find out in, let's say you got some unknown thing, you go to Mars and come back, some of you may be extras, I don't know, find the mass from the Pluto, the stay there kind of thing, right? You bring back something here and you want to analyze, oh, what elements it has got. So you put it into this thing called mass spectrometer, okay? Spectra means like, they brought up a whole a chart for you, like, no, and there's peaks and lines or whatever. Meter is to measure, okay? And they measure what? Mass. Nothing else. How heavy the particles? How do you break up all the particles, all the stones or whatever? How do you, I'll show you, okay? So now the working of this thing is not required, but I'll show you how it works. Which means that they won't ask you about the working. Now the another term here they ask you is mass spectra. Analyze means that to tell me what is it, to give information. Give information. So you must understand all these words. Otherwise, you read this, what is all this nonsense? Okay, you must understand what it means. Analyze means to give information. Okay, what is actually? I analyze your character. I say you're an idiot. You're very gundu. You're useless fellow. But no determination. Analyze your character. Or you're smart fella. You got a lot of plans. You work very hard. You are my top student. I don't think anyone you are. It doesn't matter. Okay. In terms of isotopic, this is another word again. Isotopic means isotope, right? Is it Cl35 or Cl37? Oxygen 16 or 17 or 18. Hydrogen 1, 2, or 3. Abundance means how much. How much. And they normally, in terms of called relative. Relative abundance, okay, relative, okay, or because can be percentage or actual abundance, it means how much. Got 1,000 students, okay, 500 girls, 300 boys, 200 gundus, whatever. Okay, so they tell how many, how much are they, okay now, okay. Then after that, then you need to calculate that. From this here, from the mass here, which is actually the isotopes. Okay, of all the things here, then you can actually calculate the relative atomic mass of a given element. That means a specific element. Okay, given from the relative abundances and so forth. Okay, the mass spectrum means that is that the graph thing. Okay, I'll show you. Okay. So a couple of words here you need to see, you are able to appreciate later when we talk about it. Okay, I'm going to go to now the mass spectrometer, right? So bear with me. Okay, now this is a very simple mass spectrometer. I'll show you what, as I say, mass. It means I want to find out how heavy things are, not how how beautiful things are, or how green things are, or how red things are. No, how heavy. Okay, mass. Spectrometer means is a spectrum, and meter means to measure. Okay, now so here I say vaporized sample. Actually, in some of the things here, there's a chamber here called vaporizing chamber. Okay, they call it vaporizing chamber. Because why? Because your substance could be solid, isn't it? Or liquid, isn't it? What you put inside here must be gas. No, here's all gas. From here is all gas already. So here I can put a container here, and I put a heater here. Okay, so there is a heater, okay, and a container here. So I put the substance here. Okay, right, and then I heat up. So the substance will vaporize, become gas. It can be solid or liquid here. Okay, so let's say then the gas will move inside here. That means the gas means what? They're individual particles in it. Now I'm going to give you a simple one. Okay, gas, chlorine. Let's say I got Clorox here, no, something like that. So gas, chlorine here. All right, so it's Cl2 coming out. There's a molecule in it, right? Chlorine coming out here. So as chlorine move into here, this is called the ionization chamber. That means they change to ions. Now hold on first. Okay. Now remember I got chlorine. Now you should know, right, in Form 5, chlorine got 2 isotopes. You better know. I don't know. I'm gonna kick your head. 35, 17 here, and what? Who knows? 37, 17. Atomic number or number of protons is the same, but the nuclear number is different. Why? Because the different number of neutrons. Yep. So there are only 2 in this. Well, in this world, I don't know about in Mars or Pluto or Moon. I don't know. Okay. So in this world, there are only two kinds of chlorine. They weigh differently, but they are both chlorine because it's got 17 protons, right? So of course, Cl2 can be a combination of, right? Cl2 can be a combination of Cl bonded to Cl. I'm going to go cross and dots, okay? I'm going to be a bit slow here so you can understand. Dots and then cross here. All right, and this is what you done in your Form 5 or Form 4. Right now. So this is the outermost shell, that's all, right? So this is the covalent bond here. So this is 35. So as I put it better, okay? Cl, so I got 35. The first choice is Cl35 and Cl what? 35. That's not. Second choice, of course, is what? Cl35. These are the possibilities. Cl37. Yes, not. Okay. Of course, I can have also Cl37 and Cl35. Okay. Let me switch come first. Now, this is a possibility of choices. No probability. This can come first or not. The first last one, of course, I got my Cl37 and Cl37. All these buggers here get into this area. Okay. So what happens? Right? If they come to here and nothing happens, then these are all neutral, okay? No charge here, all neutral, all is a neutral, no charge, okay? Right? No charge. So as it comes to here, what happens? Now this thing here is called a heating element. All right? I'm going to draw it a bit bigger here. May I draw it in the zoom back here? So what happens is I got here. Okay, here. Now remember, this is your ionization chamber. Ionization chamber. Okay. So now this electric. I pass the electrical field here, and this is wolfram. Wolfram, tungsten. Okay, heated strong like your bulb. No, get a lot of electrons. A lot of electrons come out. And here would be a very high positive charge. Okay, so very positive charge. So the electrons are being accelerated to it. Oh yeah. Okay, So it says unknowingly chlorine molecules, okay, Cl35, Cl37, Cl35, and Cl35. Oh, come here, come here. No. So they get bombarded. Okay, so all these get bombarded. Okay, so you have Cl35, Cl35. Now there are a few ways you can bombard this fellow here. Remember the electrons here. Okay. Of course, you can bombard and clear one of these electrons or two, okay. But normally you will control the strength from the strength of this fast-moving electrons from the voltage here. So you want to make normally you want to make up one positive charge on it, okay? Which means you want to kick out one electron here. So you can have what? You can have here will be Cl. No, there can be two. No, there are possible two electrons in it, right? Kick out, wasn't it? So let's say if it's one kick out, we assume, okay. So 35, right? So I got one here, 1, 2, 3, 4, 5, 6. Okay, that means this one has been knocked off. Okay, knocked off. So now this remains 7, 6, 7. Yeah. Okay. So now this becomes the whole thing becomes what charge? One positive, isn't it? It has lost an electron. Okay. So now normally we want to have this thing called M over E, mass over E is a charge. Look at the time. M is the mass. Now this ratio is very important because it will, the thing will move and will separate according to this unit here. Okay, now mind. Now another way, another possibility, let's say if it's Cl35 and Cl36. Okay, so it can go to again Cl35 and Cl36 and positive. Okay. Well, it's very bad. Well, fall to me. It's not to use. Okay, then there are Cl36 and Cl35. So I put that for a reason after you see why. Okay, we'll give you, of course, Cl36 and Cl35, and a positive sign here. Then a Cl30. Oh, sorry. What am I doing? Gundu. 37 lah. I say you guys should say louder. You're wrong. Yeah, it's like very stupid. Okay, 37 and Cl37. Okay, so get one knocked off, we get what? Okay, Cl37 and Cl37. Positive. So now, remember, the total mass, of course, here is 35, 70. So it's 70 over 1, which is 70. It's not. Okay? Yep. This, how much? 72 over 1. 72. This also 72 over 1. 72. This how much? 74 over 1. 74. Now I won't deal with this one first, okay? Right? I want to deal with now. If let's say I break the bonds, I break the covalent bonds, okay? Break the covalent bonds here. I break all of them here, and what happens here is I've got Cl, okay? All these possibilities are available. Cl, and as a Cl comes here and Cl gets here, they got bam, they 7 up, okay? Remember they break homolytically. What do you mean homolytically? Let me explain. This one you will see later. Okay, homolytically means like that. It means Cl dot cross Cl cross. It's called homolytic fission. Homo means say homolytic fission, which means now the arrow. See arrow when you do two, okay, it means two electrons moving. You draw half means one electron is moving. So one move back here and one move back here. So you get what? 2 Cl with 7. See now, no charge. This is the atom. This is called free radical, by the way. Okay, right? No charge. So these fellows here, as they go into your tungsten area here, well, electrons are being bombarded, shot at them. So this fellow here can come out as Cl, right? 35, and if one electron come out, it means dot, positive. If two come out, two positive, but normally it's all one positive. Okay, we won't do it two positive. And what's the other one? Cl37 positive. Okay, same. Cross. You put cross here, so it'll make it different. Okay, 6. Yep. Yes, not. Now they found out. Okay, so this 2 will be the mass or the M over E here. Okay, put the M over E here. M over E here. Okay, E is 1. So it's 35 over 1 equals to 35. Okay, it's AMU unit. Okay, no units here. Okay, so it's 37 over 1. 37. So all this, remember, all these values here, there are 4. Of course, it's only 70. It's 72 now. These 2 contribute to here. 74. So actually, there are these readings here, and of course, this one here. This will contribute to 37 and 35. All these readings will be recorded. No, why? Because as all these are formed, okay, I'm going to go back to here, right? They are passed through this thing here. These are called plates, acceleration plates, okay? And there are 3 plates. I'm going to put 2 plates there. Now this one is 110,000, okay, volts. This, of course, now remember this. All the thing that come out here is all positive one, positive ions. Okay, negative ions cannot. Okay, because they will all be plunged into this part, because this is very positive. It's all positive ions. So it comes to here. This is negative. This is normally half of this is 5,000 watts. You put that, you die, you fry. This is 0 here, final plate, and there's a hole here. So they will all be accelerated to the hole. And they pass through whole this part here. Now this is a vacuum. That means no air, nothing here. They'll float into space. Float. And this is an electromagnet, which means they can control the magnetic field here. The B. B is called a magnetic field now. Magnetic field. And the magnetic field can then deflect. You see? Because why? What comes out here, I'm going to go back to the blank here. Okay. What comes out here, right? See, what comes out at this point here? All the ions come out here. I got Cl35 positive, Cl37 positive. I got Cl35 positive. I got Cl36, Cl35 positive. Okay, I put the same again. I got Cl30, again Cl37, Cl37, and Cl37 positive. Okay. I got 5 types of, why 5 types? Because they got 5 masses, man. All 1 charge positive. So 5 different masses as they come out here, and here is my magnetic field. Okay, magnetic field. It's known that the deflection, okay, the R, because the R, and it come to here, now this is a straight line, okay? If there's no field, they will just go straight, okay? Charges are deflected by magnetic field and electrical field. Later we'll learn about electrical field, okay? Now they will come over here, they will come here, and then they will, get deflected. And they deflect according to R, the radius here, R, okay, one here. The radius is proportional to M over E, actually root something, okay, right now. So the heavier it is, right, the bigger the R, means here. Heavier means here. Lighter means more, right now, okay, right now. R becomes lighter means R smaller, see the R is smaller radius here, okay, right. So this is later you will see a lot of variation. Never mind about that. Remember, the magnetic field here is to separate the ions according to what? According to different masses. According to actually M over E. Since E is 1, that means if E is 1, that means only according to the mass. So it's called mass spectrometer. So it's like this, for example, you shoot up here, okay, small ball bearings, big, medium ball bearings, and big, giant here, small, big, giant again. So then you put a magnet here. Okay, this is the last solution. Okay, so you put here, as you put it, all traveling the same path here. Since I put a magnet here, of course the small feather will move. Okay, what is it? The middle feather will here, the big feather will be down. Okay, what's heavier, ma? Okay, heavier, is it? This heaviest. So the mass, the all together at first can be separated by different mass by the magnetic field. See? So as they get separated from here, here, see, right? Here, remember the vacuum pump, right? And they come to here and they will hit this thing called a collector. There's a collector here, or detector, okay? A collector. They will collect. They collect the ions according to the to when they come out and to the space. Okay. So then they will see. Okay. So then they will put on fire and then here they will require a chart to give the spectrum. This is called mass spectrum. Okay, I'll show you what it means. Okay. Here. This is a very junky one I can see. Okay, it doesn't matter like this all. Okay, now let's now you can come in peak spectra, or you can come in line spectra. Okay, now like if you put boron, okay, now this it's come here. Remember now boron here they show you. See the machine don't know it's boron. Okay, you put boron inside here, they will give 2 peaks, one at 10. Now how do you know it's 10? Well, what they do was at first it was empty one, okay, nothing one, okay. This is just the M over Z or E lah. Okay, this is how many times it will strike, how many times will strike the collector, and they put in 10 carbon atoms. Okay, let's say you got 10, okay, and 10 they put 10 carbon atoms, which is carbon 12. So remember here is 0, they know. So it's a carbon 12 boom inside here, carbon 12 positive, and they boom, all here. So here's 10 carbon. So here put 10. And this will be a carbon, this is 12. They won't know it's carbon, they just know it's 12, the mass is 12, because 12 will be deflected by a certain magnetic fields in. So that's how they know. So after this, then they graduate the scale here. Put, okay, 12, then they went to 12 units. 1, 2, 3, 4, and so forth. And they put it scale here. So now they put a boron. Okay? They take out boron. They know it's boron. Okay, say, hey, how many isotopes are there in boron? We don't know. So they put boron, pure boron, into the vaporizing chamber, heat it, they all become boron atoms. Okay, and they get sucked into the vaporizing chamber, and electron gun there will shoot and become B boron positive, B positive. And then they pass through the acceleration chamber and pass through the magnetic field, and they get deflected. Because the heavier boron will be what? Will be less deflected. Less deflected. Further, go to here 11. The lighter one will go to 10. So they found, after when the whole thing finished, for a certain mass, okay, right? Let's say they put 100 lah. Let's say put 100 and it should be how much? 23. Okay, right? They found that 100 of them will have this mass of 11. 23 of them are this one. So this trace out here. This is 23. This is 100. They found, in that sample, right, there are 23 atoms of the isotope boron 11. 10. There are 23 of them. And for boron, okay, the number is the number, okay? So it's got abundancy, is how abundant is it? Okay, all right, there's 23. And for boron 11, okay, the mass is 11. Why mass? Because that's the mass, the total number of protons and neutrons, and that's the nuclear number, right? Okay, now we don't care about, of course, if you want to know about boron, what is the atomic number is 5, it's not 5 here. So you want to be specific, say, I know it's 5 because I put it there. I know it's boron, it's 5 here. But it doesn't concern us because 5 is not seen in the mass spectrometer here. So, and how many of these 11 mass of this atom, you know, how many of them? There's 100. Now, these two are what? Are the isotopic mass. This is the average, right? Oh, sorry, relative. What am I doing? Okay, sorry about this. Okay, this is called the, okay, this is called the relative isotopic mass of boron 10, okay, which is 10. This is called relative isotopic mass of what? Huh? Of boron also say, of boron, right? Boron, not boron, boron 11, all right? Okay, this is 10 here, which is 11. So I found, so boron has got 2 isotopes. So boron has got 2 isotopes. Boron has 2 isotopes. But now I want to find the AR. This is your relative mass. I want to find the AR. AR is the what? The relative atomic mass of boron. I want to find the average. So so how to find the AR? Very simple, right? Find, okay, let's say that I got 10 clones. 10 clones of the fat lump there, no? 10 fellas, all fatty. 8 of them weigh 200 kilos. 2 of them weigh 202 kilos. All right? What's the average weight of them? Simple as it. So you take the average, of course, in this case, you just times up. So 10 of them, so 23 of them weigh 10. Okay? So it's 23 times 10. Plus how much? 100 of them times 11. Over the sampling, how many boron atoms are there? 100 plus 23. So if you work it out, let me bring my well. Okay, let's work it out. No need. Okay, let's work it out. Okay, 23 times 10. Okay, easy. So it's here. How much? It's 230 plus times 11 is 1100. Okay, over 123. So let's say, okay, 1100 plus 230 equals to, okay, divided by 123. 173. 173.41. Normally they ask you in 2 single figures. Okay, let's see what you got here. Okay. Whoops. What is this so? 10. 23. Average mass of, okay, what's wrong with this? 2 times, you can work it out, okay? Something wrong with this, right? Or something on my calculator, okay? Right? So it is, yeah, it should be about 10 point something. I don't know what's wrong with my what are 2, let's say 230 plus 10 times that. Equals to divided by 10.81. I see. My calculator something wrong. Damn wrong. My calculator. Okay, 10.81. Again, I tell you, 10.81. Okay, now normally they ask you, okay, these 2 3 6 figures or 4 6 figures. They want, okay, simple as it. So you can actually find now. if you talk about chlorine, chlorine, all right? I'm going to show you one answer here because I have no time already. Take a long time. Now, chlorine, you get this, okay? Right? So you remember now, chlorine here, I show you already here. For chlorine here, right? You got how many different mass? 5, is it? You know, 70, 72, 74, 35, and 37. Okay, so you got 5 mass. 3 of them for the molecule, 2 of them for the atoms. You know, all receive. Like here, 5. So the first one, of course, is 70 here. 70 is 70. I'm going to put red so we can make it clear. So this is 70. This is okay. This 75 here. So this was 74, and this will be 72. So they say analyze. Okay, what are these lines here? Now this is 35. Now this is M over Z or M over E. No, Z means charge. Mass over E. E is equal to +1. So the value here is actually the mass. No, it's the mass. See? So the mass is 35. Of course, it's 37. That means this must belong to chlorine, the isotope of 35. It must be a positive. No positive, no marks. Okay, remember this. This must be for Cl 37 positive. So the mass spectrometer tells you that whatever is going to there, there's a mass of 35 and mass of 37. You have to say that you have to come to the conclusion that there must be a single atom. Okay, so there are 2 isotopes here, all right? And they found that from here, the level here, okay, whatever level here. Let's say okay, let's say here's 900, okay, and here will be 300, around there. So that means from here you conclude that, well, Cl35 is to Cl37, right? The number is 900 is to, it means in nature, the relative of finding this isotopes is 900 to 3, or 3 is to 1. See now, more chlorine 35 to the more chlorine 7. Now, of course, this one here, okay. Now this one, of course, for 70, it must be what? It must be Cl 35 and Cl what? 37, and you put the whole thing here is what charge? Positive charge. Must put positive charge, huh? This must be what? Now this is actually called M. The N one, now this is called the whole molecule, okay? The whole molecule. This is called a molecular ion. Molecular ion. That means it didn't break up, it just became a charged ion as well. Okay? Like chlorine here, it didn't break up, it's Cl2. You know? And this, of course, is M plus 2. You know? I put here, okay, M plus 2. Why plus 2? Because chlorine has a plus 2 difference in the plus 2 difference in the isotope. You know? So plus 2. Okay? Right? Of course, plus 2, it must be belonging to Cl35 and Cl37 are not this, okay? Positive, or I'm going to put 2, okay, to show you why the height. Cl37 and Cl35 plus. Now, because they both give you a mass of 72. Now, 35 plus 37, 72. And this, of course, is 74 must be, this is, of course, M plus 4. Okay, now this M plus 24, this is actually A2 level, but, you know, teacher might as well, I think you're learning more, no? Okay, must be Cl37 and Cl what? 37 and positive, okay, positive, okay? So, now, they found that the height here, okay, let's say the same. Okay, let's say it's okay, 9. Very hard. I want to make it 900. It's easier, see? Okay, let's say 900. Okay, don't care. 900. And the found this is 600. Okay. Okay. That's still okay. Don't forget what it's on. And they found that this is 100. Okay. Okay. Now, let me go back to that one here. Why is it so? Okay. Maybe I'll do it here. Okay. See, which means if you put there Cl30, what is this rubbish? Wow, take a lot of time. Okay, let's go to here. Cl35. Cl35. Okay, right up the ratio and then to Cl. Just put 1, okay? Cl37 to Cl35 is to Cl37 is to Cl37. Okay, now this is what the mass M/E is what? Is 70 is to 70, 72 is to 74. Yeah, okay, it means these are the lines. There are lines in 70, 72 now. So why the height is 9? Why is the height 9 here? 9 is to 6 is to 1. The reason is when you look at it from the mathematical point of view, from here, I know that Cl35 is 3 is to 1 now, okay? So what are the chances to occupy this space here? How many chances there? There's 3 chances times how much? For 35? Also 3, isn't it? That's why it's 9. Okay? So the chance of occupying a 37 here, right? Right? Is 1 times. To occupy 35 is 3 now. Okay, that's means 3. Right. Now you reverse it. 35 and 37, okay? The chance to occupy here is 3 times 1, isn't it? So it's 3 times 1. Total 3, means 6. Okay? So for Cl37, 37, what's the chance of occupying space here? 1. It's 1, isn't it? So it's 1. See now? So it's 9, 6, 1. Okay? 9, 6, 1. Do you understand? Go back and think over. I don't have time to go over everything. Okay? So you can see that here, the mass spectrometer tells you a lot of things. You analyze it. Wow, beautiful, man. Okay? So remember here, it tells you, I'm going to give the blue thing again just to differentiate, okay? So whenever you find that there are 3 lines at the very end, that means these are the heaviest particles, right? 3 lines here. That means that there must be 2 isotopes. Like here, 2 isotopes. That means here is your X, this is your X2. See now? That's all you need to know for lower 6 organ. Okay? Right? So you can see that how this will tell you the kind of substance you have got. Now, the other one, of course, is they ask you what are the things you get from here. Now, let me go back to here. I just want to summarize here before I give up the last part, which is the past year questions. I took a long time. Okay. Now, information derived from the spectra or spectrum. These 2 words, all right? This is the one I know, the lines here, okay. But this is called a spectra or spectrum, okay. It's like a graph thing that tells you information. Abundances, and of course it's the M/E. This is called a spectra of a mass spectrometer. First thing they will tell you how many or what are the isotopes here? How many isotopes? Okay, and what are they? DCY applying. Okay, like I say, how many for chlorine? There's 2. What are they? Cl35 and what? And Cl37. Okay. Relative isotope mass of each I know it's 35 and what? 37. Abundances, I know that 35 is to 37 is to 3 is to 1. Then, of course, the last part to calculate the relative mass. Okay. So from the mass and abundances, mass and abundance I can calculate. Now, I'm going to show you how. Okay. See, which means, I'm going to put it here. Okay. Cl35 is to Cl37. 3 is to 1. And this is the smallest number. So the AR is what? 3 times 35 plus 1 times what? 37 over how many sampling are there? 4, isn't it? 3 plus 1, isn't it? Okay, now you do it by yourself. This is 3 times 35 gives you 105 plus 37 or 4. 105 plus 37 equals 142. 142 divided by 4. 35.5. Voila! You have been using this for ages. That's why it's 0.5. See now? Okay, you can see. Open your feast, your eyes. Sorry. Right here, 35.5, my dear, my baby. See? Because the 0.5 will tell you it cannot be 0.5 of a proton, is it? Or 0.5 of a neutron. Cannot be one. There's a 1, 2, 3. Okay, so this is how it comes out. So it's how we calculate the mass scan. Okay, now I've got about 7 minutes more or so. Okay, I want to show you the past question to come out. Okay, so that you can have a taste of how they come out. Now, okay, spectra. Now here, see all these examples and go through them. Okay, it's you're able to understand better. More examples, of course, you can understand better. Now this is the first one. The diagram shows a mass spectrum of a sample of natural occurring copper, 63, and now the isotopes must be whole numbers, cannot be half, is it not? Right? So, of course, now to first the relative atomic mass, very simple, say 7 times 63, here, 7 times 63 plus what? 3. So nice, they're putting the orders to put in for you. 3 times 65 divided by how much? 10, is it? Right? Right? Of course, you get this one now. Okay? Next one. That's the same one. I don't want to put it. Now here. Now here is a bit different. Okay? Now here. Define the isotope in terms of subatomic particles. That means that inside the atom. That means you cannot use a new you cannot use mass number, cannot use you must use protons, because what are the particles? Particles are the smallest things. They are protons, electrons, and neutrons. Okay, you must use this one, pen. So you can say that the same number of what? Protons. Different number what? Neutrons. You must use this, okay, for 1 mark. In the mass spectrometer, some hydrogen are made of HCl. Hydrogen chloride here are split into atoms, H and Cl. The mass spectrum of HCl, the whole thing is given. Chlorine has 2 isotopes. Alright, so chlorine has 2. He didn't tell you what is it. Hydrogen involved here is only 1 isotope. Actually, hydrogen got 3, but they say only 1 involved. So chlorine now, so they give you this is the thing, relative abundances. Jiggle line. There's one number is 35. Here is 40. This is your 36. This is a 37. This is a 38. Analysis. What particles is responsible for a peak mass of 35? Of course, it must be Cl 35. Because the lowest one must be the atom splitter, isn't it? Can be 1, can be hydrogen. Right now. So it's positive here, friend. What particle is responsible for a peak of 38? 30 cannot be just can be Cl, which means this one is for Cl 35. This one is for Cl 37, is it? This one must be your HCl, is it? 35 and 1 is it? To give you what? 36 That's not positive. This one here must be HCl 37 and 1 is it? We should give what? 38 is it? The positive here. The whole thing is positive. See? So what particles is responsible for the peak? 38. So we HCl 1 and put here 37. Put the whole thing here. Positive. Okay? Use the relative heights of the peaks to determine the proportions of the 2 isotopes of chlorine. Explain simply how you obtain the answer. Okay. The 2 isotopes of chlorine is Cl 35 and Cl what? 37. Okay? Right? It says give the height, the proportion. Here is to How much is it? Now, you can measure for yourself. Here, you give the exact value here. Use a ruler, draw here. Of course, it's 30 lah. Here's how much? How much here? Where is it? 30 here. Here. 10, isn't it? 10. So 10 to 30. So 30 and 10. 30 here and 10. Okay? Explain simply how you obtain it. This is the put on there relative abundances as well. Relative abundances. Okay? Abundances. Okay? Right? All right. This is from your mass M over E value. Okay? So examine the proportion. Okay. For your answer, calculate AR. Show this one. Easy one. AR. Now, what you call it? Put CL. No. There's no difference down here. So, right. So it's 3:1. Okay. So 3 times 35 plus 1 times what? 37 over 4. You obviously will get 35.5. Okay, 6 marks. Fantastic. So you can try by yourself. So later, now give it's all same, isn't it? This time set. I think give one very nice one. What time is going up? I just want to give one very nice one. Okay, 2 very nice one. No time to do lah. Never mind. We would you can do it by yourself. I'm sure you got brains in it. Okay, it's all the different types. Okay, 3, 7, 8. Okay, now here, relative mass of copper is 63.5. Which chart is correct mass spectrum of the will lead to this value? Now, why cannot be A? It's stupid. 100% 36.5. Tell me what's wrong. Who knows? Huh? Anyone not? How can there be a 0.5? 100%. How can there be a 0.5 proton or 0.5 neutron? Cannot be. Of course, A is stupid, isn't it? It's obviously wrong. Okay, you can have 36, 63 can. 64 can. 100%. It means only one isotope. Got it? Either B, C, or D. Of course, it's on here. Then you work it out. Take calculate. Of course, it's C. Okay? So this is how it come up. One more. 2 more actually. The time. No worries. You don't want to just switch off. This is a video. So you don't want to do this. You want to fail. Go ahead. I just saw from this fellow say, a fool which plans will beat the genius who does not plan. Quite good quote. So you plan your time. Okay, this gundu here. That is really idiotic. Never mind. 291. I want to show you all the different type of questions as well. Okay? See, Emma is using here. Emma, okay? Later, we calculate a lot of Emma. Okay, now here. Okay? They say it's neon. That means neon, that means you know neon here. What is neon? Neon, the mass is 20.2, isn't it? That means you need to know when to take your stupid hand and go and take the data point and tell me. That means neon is neon, the AR for neon. You can find from the book already. It's 20.2 because they tell you. So what is the mass number here? X. Percentage abundance, see not? See. So X times this one here, plus this times this, plus this, over. Here we should give you 100, isn't it? Right? So percentage, so add up here. Can? The new relative molecular mass. Okay, now last one. Last one. Nice question. This is a very nice question. Okay, 417. Come on. This one is a very stupid one. Okay. 417. 417. Very nice question. We've seen this earlier before. 41, good night. 416. 416. 417. Oxygen one. Wait, 441. Here, 416, sorry. Oxygen is 3 stable isotopes, okay? O16, O17, O18. All 3 isotopes are present in the sample of oxygen gas, O2, which is analyzed using a mass spectrometer. How many peaks of O2 plus are there? Which means, remember, so you can work it out. Unless you're a genius. No, none of you are. Okay. O17, O18. Okay, so 3 different things, of course. Remember, O2. So the first, of course, one by one, okay? O16, O16. O16, O17. Okay, don't have to reverse because it's just to mask reverse the same. O16, O18. So it's like a three combination. O17, O17. Okay. 16 and 17 so don't want to care. 17 and 18. Okay. O18 and O18. O18 and 17 got already. O18 got. So how many? Now all must this 32 is not. 32 this 33. This 34 is not. Plus 1 plus 2 is not. Yes not. This what this is 34. This what 35. 36 is not. Yes not. All plus 1. So what's the MOE? How many there? How many? 1, 2, 3, 4, 5. 6 peaks. That's for how many peaks. Okay, babies. Okay. So now this is how they use the mass spectrometer. I want to talk about diffraction, but no time. Okay. So anyway, I'll try to do one tomorrow. I'm quite lazy, actually. Okay. So we will do step by step slowly. You have to take a time to go over again until you master it. Okay. I can give you more questions later in class. We can discuss that. All right. So I want to stop recording.